Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of substitution by matching. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again and then start at step 1. Step 1 says to set u equal to the expression raised to the power. Well, u is x squared plus 3 then, because x squared plus 3, that quantity is raised to the third power. Step 2 says to compute du dx, that's the derivative of u with respect to x. That's easy enough. The derivative of x squared is 2x and the derivative of 3 is 0. So du dx is simply 2x. Step 3 says to solve for du. Again, easy enough. Just multiply both sides by the quantity dx. The dx is on the left, divide out, and you find that du is 2x dx. That takes us through the first 3 steps. They flow together nicely. Step 4 says if the integrand has a numeric, that means just a constant, just a number. If it has a constant factor, move it outside of the integral. Well, here the 8 is definitely a constant factor inside the integral, so we'll move it outside. We can always take a constant factor outside of the integral sign. First 4 steps, very straightforward. They sort of flow into each other. Step 5, read it closely, take it step by step. Step 5, first of all, says to reconstruct the integrand so that the u part is followed by the du part. And then remembering that we can compensate by a constant factor if needed. In other words, we can insert a number as a factor inside the integral as long as we compensate by multiplying by its reciprocal on the outside. If we need to do that, we can. But let's go back to the first part, which says to put the u part first, followed by the du part. Well, that should be easy enough because we're looking at that integral. The 8 is just sitting there. It's still going to be part of the answer, but we're not focused on it right now other than to keep copying it down. We're focused on the integral itself. And step 5 says to put the u part first. Well, remember, looking back over at the setup when we found out what u was in the beginning, u is equal to the x squared plus 3, so the u part is not only the base, the thing that we call u, but it's also inclusive of the exponent. So the u part is u to the third. It's the expression raised to the third power, not just the thing we call u. Once you get used to that, it's easy enough to remember. So we want to put, according to step 5, the u part first. What about the du part? Well, the du part is always going to have the dx and whatever else is in the integrand that didn't get absorbed into the u part. And that would include not only the dx, but also the x. So looking back at the integrand, both the x and the dx are part of the du part because they're not part of the u part. The du part is everything that didn't go into the u part. Now step 5 says to put the u part first. So if you want to remember that as you're going along, you're going to put the u part first, and everything that's not in the u part is going to go to the right of the u part and is going to get absorbed into the du part as well. But the 8 just follows along for the ride. So just keep writing the 8 down, focusing back on the integral. I'm going to do exactly what step 5 says. It says to put the u part first. Well, the u part was the x squared plus 3 to the third. That's the u part. It needs to go right after the integral sign. Everything else is going to go next. So that x that used to sit just to the right of the integral sign, because it's going to be part of the du part, gets moved over next to the dx. So far, so good. We've done what step 5 says down to the part where it says remembering. So let's read that part. remembering that we can compensate by a constant factor if needed. Well, is it needed? And the way you tell is by looking back at your du. And if you look back down here at the du, you will notice that there's a 2 sitting there. But there's no 2 sitting up in front of the x dx in the du part in the integral. That's what you need to know. Because the 2 down here, where the du is determined, is not present in the integral itself, that means that we have to indeed compensate by a constant factor, that factor being the 2 that's missing. There's no 2 in that integral, but we need a 2. But we can do that. All we have to do is go to the du part, put in a 2. Now it's there. That's okay as long as you multiply by the reciprocal on the outside of the integral sign. So far, so good. We can do our little arithmetic along the way as we go, so you might as well go ahead and say that 8 times a half is 4. And now we can focus on the integral again. And the integral itself can be substituted because now we've just gotten to step 6, which says to substitute the u and the du. Notice that the x squared plus 3 is what we called u. So that's where the substitution comes in. We actually call it u. But what about the rest of the integral? The rest of the integral has this 2x dx. That's the du part. What about that? Well, that's what we call du. If you look over here, that's the du. So it's just a direct substitution. The x squared plus 3 turns into u. The 2x dx turns into du. And of course, that 8 times 1/2 makes 4. We're down through step 6 now. But don't ever forget that we're still focusing on the integral itself. That numeric factor, whatever it happens to be, in this case a 4, just sits there. It will eventually get multiplied through, but right now it just sits. We're interested in that integral here. And as a matter of fact, in order to finish this off, we probably want to get rid of some of that clutter. So let's take some of that clutter away. After you copy the 4 back down, the integral itself should remind you of the general power rule for integration, which says that we can evaluate the integral of u to a power, and we do that by increasing the power by 1 and multiplying by the reciprocal, or 1 over the power, on the outside. We've been doing that for a while, so that should be fairly straightforward. So if we want to integrate u to the 3rd using the general power rule for integration, the new power will be 1 higher, which makes 4, but we have to multiply by 1/4 on the outside. But please don't forget that this 4 is still sitting there. So that 4 does not go away. And in fact, it will multiply by the 1/4 to give us 1 eventually. The other thing you don't want to forget is that this is an indefinite integral. You have to put plus c. That allows for the possibility, if you're thinking backwards, of this integral being an antiderivative. If you went back and took the derivative of the antiderivative, if there were just a number added, its derivative would be 0. So there's no way to tell if there was a number or not. So you put a plus c to allow for that possibility. Now the hard part's over. 4 times 1/4 is just 1, so you get 1 u to the 4th plus c, or just u to the 4th plus c. We've done the calculus now, but keep in mind there was no u in the original problem. We introduced the u. So the last step is to take the u back out. U was equal to x squared plus 3. So it becomes quantity x squared plus 3 to the 4th power plus the constant of integration c. And that's the answer. Remember, you can turn right around and take the derivative of your answer and prove to yourself that you really do get what's between the integral sign and the dx for its derivative, and that can assure you, if you're a little bit hesitant whether you did it correctly or not, that can assure you that you in fact did get it right. Or conversely, if you did make a mistake, it'll show up when you take the derivative of the answer and see that it really is not equal to the integrand. Either way, taking the derivative of your answer and checking it against what you started with is not a bad strategy.